Okay, am I live now? Am I live? I think I am. Okay. Hi. I was talking for like 2 minutes and nobody could see me because I didn't hit the button that said go live. So yeah. Anyway, this is going to be an Algebra 2 finals review stream. Yeah, so it's going to be 10 problems just like the last one. I tried to pick out some different kinds of problems. So there's going to be a different kind of logarithms problem. There's going to be things on equations of lines like point slope form, different things that I haven't covered in the previous videos, along with like a mix of some stuff I've already covered. So yeah, this will just be a little 10 question review for your final exams. If you're watching the replay afterwards, then you have the ability to pause. So I would recommend that before each video or before each question, you pause the video, try to do it yourself, maybe on pencil and paper, go as far as you can, and then unpause and see how far you can get. And then learn from your mistakes. I feel like that's the best way to learn. But you could also just watch the video. That's fine too. All right. So we're going to get started with the first problem, assuming that I'm actually live now. Yeah, looks like it. Okay. So the first problem is a solve for x problem, but it's an inequality. So that's because it has this less than sign here instead of an equal sign. So at first, that's not going to change anything that we do. We're just going to solve for x normally, but it's going to change something that we do at the end. So we need to get x by itself on one side of the equation or the inequality. And we have a choice. We can get rid of the -2 first, or we can get rid of the +5. So I usually like trying to get rid of the one that's less attached to x. In this case, the 5 is less attached. This -2 is like right next to it. So what's the opposite of plus? Minus. So we're going to subtract 5 from both sides. So these cancel out. And on the left side, we have -2x. And on the right side, we have -3 minus 5. So think of this as dollars. You lost $3 and then lost another 5. So you're down 8. So here's the one thing that's different. The inequality sign is going to stay the same throughout the entire problem, except when you multiply or divide by a negative number. So it's going to stay the same right now, but as you'll see, here we might run into that issue. So here we have multiplication. When there's no sign between a number and a letter, that means it's multiplication. So we'll do the opposite of multiplication, which is division. And we'll divide both sides by -2. So these cancel out. And on the left side, we just have x. And on the right side, we have 8 divided by 2, which is 4. And we have two negatives, and two negatives make a positive. So these are going to become positive. And then you see that we divided by a negative number, or if you multiply by a negative number, it does the same thing. That's when you have to flip the sign. So this was less than, now it's going to become greater than. So that makes our final answer, x is greater than 4. So yeah, that was our first problem, inequality. I realized I forgot to put in the chat, feel free to ask questions. There you go. And can we pin that? Well, let us pin that. There we go. Okay. So let's move on to the second question. And I will go ahead and switch our number to 2. Crazy. And we'll go ahead and erase what we have here. So how was everyone's finals season going? It's almost summer for a lot of you. I just closed out my questions. There we go. Okay. So for the second one, we need to find the slope of the line that passes through the points -3, -5, and, or sorry, that is -3, +5, and 2, -1. And we have to find the slope. So how would we do this? So for this, we're going to use something called our slope formula. So the slope formula There's two ways that it's said. You might have heard it as rise over run, or you might have also heard it as the more mathy way to say it, which is y2 minus y1 over x2 minus x1. But they both actually mean the same thing, because rise is just how much it's going up and down, and y also is up and down. So we're seeing how much y changes. That's the rise. And then the x is our run, how much x is changing. So to find the slope, we just need to plug in the numbers into our slope formula. So y2 and y1. So remember that for points, it's x first and then y. So for this point here, this is a point. X is the number on the left and y is the number on the right. And this point here, we will call point 1. And then this is point 2. So y2 is the y of the second point. So this is our second point, and the y is the point on the right, or the number on the right, which is -1. Then we take minus y1, and y1 is the y of the first point. So that will be the first point here on the left, but y is the number on the right. So that will be +5. Then we will have x2 minus x1. So x2 is the x of the second point. So the second point is the one right here, and x is the number on the left, which is 2. And then finally we have x1, which is the x of the first point. So the first point is here, and the x is the number on the left, which is -3. So this is actually going to be -3, but remember that two negatives make a positive. So I'm just going to write +3 because the two negatives make a positive. And now we just simplify our fraction now. So we have -1 minus 5. So think of it as dollars. You lost $1, you lost another 5. So you're down 6. And then here we have 2 plus 3, which is 5. So we can't actually simplify this fraction down, right? There's nothing that we can divide off the top and the bottom. So we're just going to leave it like that. So this is our final slope of these 2 points. So that's how we find slope. And remember that this is the same thing as rise over run. And this is the same way you would find slope if you had a graph. And you were like, it might seem different because you're counting boxes, but you're actually doing exactly the same thing. It just looks different, but it's the same formula. So yeah, that is the second problem. The next one's kind of similar, but it's going to be slightly different because we are going to be writing an equation. So I'm going to switch to number 3 here. And we're going to get started with our third problem. So our third problem is we're writing the equation of a line, and this is our information. Our line has a slope of 2, and it passes through the point 2, 3. So we have to figure out what the equation would be of this line. So remember that the equation of a line can always be written in y equals mx plus b. And that is our end goal, right? We want it to be in y equals mx plus b. But the only problem with that is that, well, m is really easy, right? M is our slope. Well, the letter itself isn't easy. I don't know why they use the letter m, but it's easy. We just plug in the number 2 here, right? But what is b? Well, b is our y-intercept. And the y-intercept is, well, we don't have that, right? The y-intercept is what y is when x is 0. Hydration break. So we don't have our y-intercept, right? So how are we going to figure out how to put this into y equals mx plus b? Well, we have another format that is going to help us even more here, and it's called point slope form. So the last one, y equals mx plus b, that's called slope intercept form. So this one is point slope form, and it goes y minus y1 equals m times x minus x1. So this is another way to write the equation of a line. But the difference here is we can use this with different information. So we still need to have the slope, right? But we also have y1 and x1 instead of b, which was our y-intercept. So these are where we plug in any point on the line. And we do have a point here. We have 2 and 3. So that's going to be really helpful for us in writing the equation of a line. So remember that when we're writing an equation, y and x, just the normal y and x, not the ones with ones, those are just going to stay the same because in an equation, like for example, you would have y equals 2x plus 3. You don't put anything in for y and x, they stay y and x. And then if you wanted to later, you could plug in a number for x and get something out for y. But yeah, so y and x are going to stay the same. But everything else we're going to replace with what we know. So y minus, now we have y1, which just means the y of the point that we know. Can't you just solve for 2x plus, oh, it's gone. Okay. So we have y minus and then y1, which is the y of our point. And remember that the y is the number on the right. So the number on the right is 3. So we'll put in 3. Then here we have m, which is our slope, our slope. And in this case, that's 2. So we'll put a 2 here instead of m. X is going to stay the same, like I said. And then we're going to put our x of the point. And the x is the number on the left, which in this case is 2, just like our slope. So we have our slope-intercept form equation, but that's not like the normal way to write an equation. Like you can see there are things that can be simplified here. We can do this distributive property. So our goal here is eventually, and I'll go ahead and erase this. We eventually want to get this, well, actually, let's not erase that. Let's keep that up there in case people are joining in and want to see that. But our end goal is to get this into y equals mx plus b. And to do that, we need to get y by itself. That's our goal. So eventually we're going to get rid of this minus 3, but first I'm saying that we can do the distributive property here. So whenever you have a number in front of parentheses, then that means that you have to multiply the number out to both parts of the parentheses, or all the parts if there are more than 2. So the left side is going to stay the same. And then on the right side, we're going to do our multiplication. So here we have 2 times x. You can't multiply a number and a letter, so it's just going to stay as 2x. And then we have 2 times negative 2. Negative signs are really important to remember. Probably one of the most common mistakes is forgetting negative signs or like losing track of them. So we have 2 times 2 here, which is 4. And then we have 1 minus sign. So the minus sign stays as well. So now we have that simplified. And what I was saying was we can get y by itself. So to get y by itself, we need to get rid of this minus 3. And the opposite of minus is plus. So to get it by itself, we'll add 3 to both sides. And I'm putting the plus 3 here under the minus 4 because they're like terms. They're numbers, so we can add them together. So these cancel out. And on the left, we just have y. And on the right side, the 2x is just going to stay on its own. And then here we have minus 4 plus 3. So using the dollar analogy, we lost 4, and then we got 3 back, but we're still down 1. So it's going to be minus 1. And yeah, this is our final equation for this. We have a slope of 2, as you can see from m being 2, and then it passes through this point. But our y-intercept is actually negative 1 because we didn't have our y-intercept here, but we figured it out through using point slope form first. So yeah, oh, that's how it's supposed to fall down. So yeah, there's multiple ways to write the equation of a line. So this is how you would do it if you have a slope and a point, or if you have, for example, if all you had was 2 points and you didn't have slope, well, then you would have to figure out the slope through those, just like the last problem we just did, and then do point slope form. So if you had 2 points and you had to write an equation, you would actually combine these 2 problems that I just did. So yeah. So that's for finding the equation of a line with given information. And we will now move on to question 4. Wow. Number 4. Let's see. Ooh, okay. So this is a quadratic equation. We have 3x squared plus 5x minus 2, minus 2 equals 0. And we have to solve for x. Now, I did a quadratic equation in the last stream, but I did it using completing the square. And completing the square is really only practical if this number wasn't here. This number here is annoying. Having a number in front of x squared makes it longer. But that's why I'm showing you how to do it so that it can not annoy you anymore. So there are tons of ways to solve it. So completing the square we're not going to do. The two main ways other than that are factoring and quadratic formula. So quadratic formula works every time. Factoring sometimes doesn't work. But for this one, we're going to use factoring because it's the fastest way to do it usually. And yeah, I just want to make sure that you're familiar with different kinds of methods because it might say like solve this using factoring. So it's helpful to know how to do those things. But factoring is a little bit harder when we have a number here in front of x squared, like when it's not just 1. Because remember, when there's not a number in front, then that means it's just 1. There's like an invisible 1. So here's how we would normally do it if there was not a number in front of here. What we would normally do is we would take this number, and this is our adding number, and this is our multiplying number. And our goal would be to find two numbers that multiply to this number and add to this number. Does that exist? No, that doesn't even exist for this. So we're not gonna. So this would be impossible. But in this case, we have a 3 here, so that's going to slightly change how we do it. It's pretty similar, but I'm going to be using something called the X method. I don't know if this is what you guys were taught, because yeah, I know some textbooks do like trial and error. It's kind of weird. I think it's pretty similar, but yeah, the X method is how I learned it. So this is what we're going to use. I'm actually going to make this a little bit bigger. Let's try that again. Good enough. Okay. So here's our x. And what we're going to do is we're going to take this number, which is normally our multiplying number, right? And don't forget that it's minus 2, because the minus always is included. We're going to multiply it to our number in front. So minus 2 times 3, 3 times 2 is 6, and then there's one minus sign, so the minus sign stays. So this is our new multiplying number. We're going to find two numbers that multiply to negative 6 instead of negative 2. And then this number here is going to stay the same. It's going to be positive 5. And that's still going to be our adding number. So for this, we need to find two numbers that multiply to negative 6 and add to positive 5. And, well, for that, we're just going to have to test out numbers, right? So I like to start with the multiplying number, find two numbers that multiply to negative 6, and then see if they add to 5. So numbers that multiply to negative 6, remember that, so the way that I like to think about this is ignore the minus sign, right? Let's just put numbers that multiply to 6. So the only ones that exist are 1 times 6 and 2 times 3. So let's try 1 and 6 first. Now, the reason we're ignoring the minus sign is because 1 times 6 is 6, but because there's a minus sign, that means one of these has to be negative. And we know that because we're adding to a positive number, it's the smaller number that has to be negative. Because if the 6 was negative, then we would be getting a negative number if we add these together. But we're looking for positive 5. So that means our smaller number, which is 1, has to be the negative 1. So negative 1 times 6 is negative 6. And if we add these together, remember this is the same thing as 6 minus 1, which is 5. And that is the number we're looking for. So on our first try, we already got it. But yeah, I'll just show you if we were to test out 2 and 3, then we know that the negative has to be on the smaller number, and 3 minus 2 is 1, which is not the number we're looking for. So we're looking for 5, right? So I'm going to move this up. So this tells us that our two numbers are negative 1 and 6. Those are our magic numbers for this problem. So one more change, because this number here is not 1. So if this was 1, then what we would do is we would just take our numbers and put them in parentheses. So we would have x times x, and then in the parentheses, we'd put our numbers. So we'd have -1 and then +6. And then we would solve it. But we have to do something slightly differently. So we're going to still put our numbers in the parentheses. So we're going to have -1. Well, we'll put them in the parentheses eventually. But we actually, sorry, I forgot this part. So we need to take our two numbers before we put them in parentheses. We need to put them on the right and left sides of our x. So here's our x, and the numbers are going to stay the same, except we need to divide one of these numbers by this. So so we're basically dividing one of these numbers by 3. If it was a bigger number, like let's say it was, 4, for example, you could divide one of the numbers by 4, or you could split it up. You could divide both of them by 2, because 2 times 2 is 4. But to keep things simple, we're just going to divide one of these by 3. And the only one that can be divided evenly by 3 is the 6. Because if we divide this by 3, then we just have fractions. And fractions are no good. We don't want fractions. But if we divide this by 3, 6 divided by 3 is 2. Which means that our two numbers that we're going to put in parentheses are -1 and 2. Those are going to be our two numbers. So we're going to set up our parentheses, and we're going to put our numbers, -1 and +2. Let me make this a little better. There we go. So here's the important part. You can't just slap an x in both of these. You have to put 3x on one of them, because we have a 3x squared here. But you always put it on the opposite one that you divided by. So if that doesn't make sense, here, I'll show you. So basically, because we divided the 3 out on the 6 to get 2, then the 3x is going to go on the opposite side, which is -1. So the 3x is going to go here, and then the regular x is going to go here. And the reason for that is because if we were to do FOIL, like if we were to reverse this, FOIL is how we take something that's already factored and turn it into something like this. And FOIL is first, outer, inner, last. So it would, and the first step is first, so 3x times x. But then the second step is important. Outer means we multiply these together. And you see now why we put the 3x on the opposite side, because we end up multiplying the 3x and the 2 together to get 6, which is what we had originally. So that's why we need to put the 3x on the opposite side as the number that we divided by 3. So now we have our factored quadratic equation, which is most of the problem done. But we still have to solve this. So how would we do this? Well, if this wasn't equaling 0, then we're cooked. But it does equal 0. And by the way, if it didn't equal 0 originally, you would need to like if this was a 3, you'd have to subtract 3 from both sides to get it to be 0, because this only works if this is 0. And it's a math rule. Anything times 0 is 0. So if let's say this part here is 0, and remember that these are being multiplied together. If this was 0, then the whole thing would be 0. Even if this was 5 quintillion, then this would still equal 0, because anything times 0 is 0. And the same thing would occur if this part was 0. If this was 0, the whole thing is 0. So because of that, we can actually split this up into two equations. I'm going to move this over because I'm realizing there's not much room. So let's move that here. And then let's move this here. Okay. So we can split this up into two equations. If 3x minus 1 is equal to 0, then the whole thing is 0, and the equation is true. And if x plus 2 is 0, then the whole thing is 0. So just because it's equaling 0, we can split this up, only because it's equaling 0. So now we just solve these for x like normal to get our two answers. And yes, quadratic equations almost always have two answers. Sometimes they don't, but most of the time they do. So here we have 3x minus 1 equals 0. So to solve for x, we'll just get rid of the 3 and the minus 1. The minus 1 is less attached to the x, so I'll get rid of that first. So because it's a minus, we have to do the opposite of minus, which is plus. So we'll add 1 to both sides. These cancel out. And on the left side here, we just have 3x. And on the other side, we have 0 plus 1, which is 1. And now we have a one-step problem. So these are being multiplied. So we'll do the opposite of multiplication, which is division. We'll divide both sides by 3. So the 3's cancel out. And here we just have x equals 1 divided by 3. That can't be simplified, so it's just 1 over 3. And this is one of our answers. Now let's go over here. This is a little bit easier because it's only one step. We have a plus 2. We'll do the opposite of plus 2, which is minus 2. So we'll subtract 2 from both sides. So these cancel out. And on the left side, we just have x. And on the right side, we have 0 minus 2. This 0 is not doing anything, so it's just minus 2. And this is our second answer. So these are our two answers, 1/3 and minus 2. And if you wanted to check your work, then all you'd have to do is plug 1/3 and -2 back into the equation, like make this 1/3 and this 1/3, or make them both minus 2. And both of those times it should work. It should end up equaling 0. So that's how you would check to see if you're right, if you had like extra time on your test or anything like that. So yeah, that's how you factor quadratics. It's a little bit harder because that number wasn't 1, but this is the process. So yeah. And as always, if you didn't want to do this and you do have the choice on an exam, you can also just use the quadratic formula. So I talked about that. Did I do it on the last? No, I didn't do it on the last live stream, but in the finals video, I did do quadratic formula. So if you want to watch that, then to learn how to use the quadratic formula, then that is available. So yeah, we will move on to question 5. And of course, we have to do our thing. Okay. So question number 5, we're almost halfway there. So we need to simplify the square root of -45. So very short problem. Maybe not short to do, but just short to write, because this is it. This is the whole problem. It's not moving. Do I have to? Okay. All right. Square root of -45. So first of all, this should already look sus because you can't take the square root of a negative number. And the reason for that is because a square root is basically the number that you have to, yeah, it's the number that you have to multiply twice to get it. So for example, the square root of 49 is 7 because 7 times 7 is 49. But the problem with this is -7 times -7 is also positive 49 because two negatives make a positive. So taking the square root of a negative number is impossible. Oh yeah, I saw the right answer there. Yep. I'm pretty sure that was right. Yeah. So this needs to be simplified, but it's a negative square root and those are impossible. So what do? Well, that's why we have these things called imaginary numbers. So they're imaginary because they don't exist in the real world. You can't have an imaginary number of M&Ms. You can't have imaginary numbers in the real world. But the reason that we have them in math is because they can turn back into real numbers. So how do we do this? Well, our favorite imaginary number is the letter I. And the letter I is what we give to the square root of -1. So to turn this into the letter I, we need to split this up into two square roots, because if you multiply two square roots together, then like you can split it up. Like for example, if you had the square root of 5 times the square root of 6, then that's the square root of 30. You can do that with square roots. So we can split this up into two square roots. There are more imaginary numbers than just I. Well, no. I mean, technically, because, like, for example, 2i is also an imaginary number. Like you would just say that this is an imaginary number, but I is the only letter that we give for imaginary numbers. So actually, I've heard that some people use the letter J for some reason, like in engineering or something. I don't know why, but yeah, sometimes the letter J gets used, but usually it's I. So we need to split this up into two square roots. So we need to have the square root of -1 because that's going to turn into I. But what other square root would we use? Well, let's just use +45 because the square root of -1 times the square root of +45 gives us -1 times 45 is -45. And this is going to turn into the letter I. So this is going to become I, right? And now here we have the square root of 45, which that's not a nice even number because if you think about our perfect square numbers, I think it's because I is already used for, yeah, that's what I figured. I wasn't sure what it was, but I just remember learning that I is already used for something in engineering. And so that's why they use J. But yeah, it's weird that like because I and J are such like similar letters. So like I wonder if people get like confused over that. But yeah. But I think that's why the letter J gets used sometimes. So the square root of 45 is not a perfect square root because the square root of 36 is 6 and the square root of 49 is 7. And by the way, you could just know this from 6 times 6 and 7 times 7. So the square root of 45 falls in between these two. So that's how we know that it's not going to be perfect. But we can actually still simplify this because the square root of 45 can be split up into different square roots. And we just need to figure out if we can divide out any of our magic, like perfect square numbers. So, for example, 4 is a perfect square number because that's 2 times 2. But we can't do 45 divided by 4. That's going to give us decimals, fractions. And if you didn't know that, you can put it in your calculator. It would give you like 11.25. And then what about 9? Because 9 is 3 times 3. And 9 actually works here. 45 divided by 9 is 5, like perfectly 5. So what we can do is actually split this up into two more square roots. The square root of 9 times the square root of 5. So let's just go ahead and simplify this down. So the I is going to stay the same. The square root of 9 is 3 because 3 times 3 is 9. And the square root of 5, there's nothing we can do with that. So that's going to stay the same. And yeah, we're basically done for simplifying. The only thing that's left to do um, is to kind of make this look a little bit cleaner because remember that in algebra, you don't have to put the multiplication symbols. You can just put things next to each other. So usually I like to put the number first and then the I and then the square root because to me this just makes sense because we normally put letters or we normally put numbers before letters anyway. And then this just makes sure that nothing is inside the square root. Like you could also write 3 square root of 5 I, but you just have to make sure you make it really clear that the I is not inside of the square root. Because if you accidentally make the square root line a little bit too long, now the I is inside the square root, and that's a different answer. So this is just how I like to write it, but it doesn't actually matter. Any of those work. So yeah, that's how you simplify the square root of -45. And yeah, imaginary numbers are a little wonky. I have done other imaginary number problems, especially when you get to like I squared, I to the third, and they do wonky things. So yeah, those will be helpful to know. I don't think I have a problem on those for this stream, but yeah, if you want to look into those, that would be a cool thing, a good thing. Oh, never mind. The next problem is about what I was just talking about. Okay, the wonkiness. So let's go to problem number 6. And for this problem, we need to multiply these complex numbers. Okay. So 2i minus 4 times 3i plus 2. So we need to multiply these complex numbers. How do we do this? So for this, we are going to use something called FOIL. And I already talked about it earlier. But basically, even though these are fake numbers, these are our imaginary numbers, we can actually still use FOIL because it's two sets of parentheses with binomials in both of them. Binomial just being a super fancy math term for a thing with two things. So thing one, thing two. Now we have our binomial. So basically we need to multiply these together using FOIL. And I'll go ahead and write out FOIL because this will help us know the steps. And by the way, when I say complex numbers, that's just a number that's part real and part imaginary. So this is a complex number because we have I was about to point to here. This is our real part. This is our real part, and this is our imaginary part. I think normally you actually write the real part first and then the imaginary part. That technically doesn't matter, but yeah. But I forgot to do that this time. It's fine, guys. I'm good at math. I know what I'm doing. Okay, so we're going to do the first step here, which is F. And the letters in each thing of each letter of FOIL stands for a step. So the letter F stands for first, and that means we need to multiply the first parts together. So we have 2i times 3i. So we'll multiply the numbers and then the letters. 2 times 3 is 6, and then I times I is I squared. But we're not going to leave that as I squared, but we'll get to that later. We'll just leave it like that for now. The next step is O, which stands for outer. So we need to multiply the outer parts together. So we have 2i times 2. So we're going to treat this I just as if it was a normal letter like X. So 2 times 2 is 4, and then the I stays. The next step is I, which stands for inner. So we're going to multiply the inner parts together. So this is going to give us, and this minus sign is going to stay. So I'll move this over a little bit. Actually, this is going to give us a minus sign. So 4 times 3 is 12. And the I will stay. And we also have one minus sign. So the minus sign is going to stay as well. And then finally, we have our last step of FOIL, which is L. And that stands for last. So to do that, we need to multiply the last parts together. So that's 4 times 2. 4 times 2 is 8. And we have one minus sign, so the minus sign is going to stay. So we followed the steps of FOIL, and we've gotten this. So what can we simplify so far? Well, first of all, if we're just treating I like it's a variable, right? I'm seeing that here we have two parts with an I next to them. This one is I squared, so we can't combine that, but we can combine the two parts that have I. So everything else is going to stay the same, but here we're going to combine these. So we have plus 4i minus 12. So we gained 4 and then lost 12. So we're down 8. So that's going to be minus 8i. And then the minus 8 here is going to stay the same. So the letter I here by itself, there's not really anything we can do with that. But here we have I squared, and there is something that we can do with that. So to demonstrate that, remember that I is the square root of negative 1. So I is the square root of negative 1. So I squared is the square root of negative 1 squared. But what can you do with this? Because you see that we have a square root and it's being squared. So those actually cancel out because they're the opposites. Square rooting and squaring, they just do opposite things. And all that we have left is minus 1. So I squared is actually the same thing as minus 1. So we're going to replace I squared with negative 1, and we're going to write everything else the same. And now because of that, we have more simplifying to do. So here we have 6 times 1, which is 6, and one minus sign, so the minus sign stays. Minus 8i minus 8. And now there's one more thing we can do. There's one more thing that we can simplify, and that is because we have two regular numbers here, -6 and -8. And if we combine those, lost 6, lost another $8, so we're down 14. So it's -14, and then the 8i is going to stay. Remember, there's a minus sign on it, so that has to stay as well. And this is our final simplification. Remember, there's nothing else we can do with this because it's just the I by itself, and it's a complex number again. We have our real part, which is -14, and we have our imaginary part, which is -8i. So that's how you multiply complex numbers. And this is also helpful for not even if we're not even talking about imaginary numbers. Like if you just had like x plus 3 times x minus 2, this is exactly how you would do it, minus the special I squared stuff. So if you think about it, this is actually kind of the opposite of our factoring problem. Factoring was taking whatever we had and turning it into this parenthesis format. FOIL is how you do the opposite. It's how you take your parentheses and turn them back into something else. So yeah, that is FOIL with complex numbers. So yeah, we will move on to question number 7. So yeah, this is getting to a little bit of the new stuff. So this time I wanted to do this problem because last stream someone mentioned it. So hopefully I can. Okay, so x plus 3 is a factor of, and then we have a cubic equation plus 5x squared minus 2x minus 24. And then we have to find the other factors. So someone was asking about this in the last stream, and I said, that the problem would take a little too long for the end of the stream, but we have time now. So I'm going to go ahead and go over how we would do this problem. So I'm saving a little bit of time here because it tells us what one of the factors is, and that's going to save us a lot of time. If it didn't tell you what one of the factors was, then we would have to keep guessing numbers and seeing if we can figure out a factor. But because we know what one of the factors is, then the way that we figure this out is through synthetic division or long division. Either division works, but we need to use, well, synthetic division is going to be easier because you can use synthetic division if you just have x minus something or x plus something is the thing that you're dividing by. So here's how we find the other factors. We need to take this. So I'm actually going to write this out. So we need to divide our cubic equation all right, and then we are going to divide out this. So we divide out one thing that we know is a factor, and this is actually what we would do with like normal numbers. So I know it seems weird that we're dividing, but think of it like this. The two factors of 20 are 5 and 4, because 5 times 4 is 20. So if we knew that 5 was a factor, then to find the other one, which is 4, we would just divide 20 divided by 5, which is 4. So dividing is how you find other factors. So here's how we're going to divide these. What we're going to do is we're going to take our x plus 3 here, our simple part, and we're going to take the number here, and we're going to put it in our special synthetic division box. So we're going to, but you have to flip the sign. So for our special commanding box, I think is what I called it last time, we have to change the sign. So it was a plus 3, then it's going to be -3. And if it was x minus something, then it would be positive. So that goes in our cool little box. The factors of 20 are 2 and 2 and 5. Yep, that's good. Yeah, those are factors. So you can have like multiple like tons of factors. So but it's the same thing just with letters. So it's more complicated, but it's the same principle. So this is our little special synthetic division artwork. We have our number in our box, and then we are going to write out the beginning numbers of each of our long part. Actually, I'm going to point down here. So this first part here, we don't have a beginning number because it's invisible. We have an invisible 1. Whenever you don't have a number in front, that means it's 1. So we're going to write out all of our beginning numbers. So here we have 1. Here we have 5. Here we have -2, the minus sign stay. And then our last number, the one by itself, -24, is going to go above our remainder here, our trash can. I don't know, I just made that up. We're going to call this the trash can from now on. So now what we need to do is do multiplying and adding. Multiply, add, multiply, add. That's the process. So we're going to start by bringing down this number, which is 1, and then we're going to multiply and add. And we always multiply by the number in the box here. So we're going to multiply here. So 1 times -3, anything times 1 is itself, so that's going to be -3. And then we add. So 5 minus 3 is 2. Then we repeat the process. So 2 times -3, we always multiply by the thing in the box. 2 times 3 is 6. And we have 1 minus sign, so the minus sign stays. And then here we have -2 plus -6. So think of it as dollars. We lost $2 and lost another 6. So we're down 8. Then we do it one more time. 8 times 3 is 24. And we have 2 minus signs, 2 negatives make a positive. And then -24 plus 24, those cancel out and give us 0. So if we were doing synthetic division, just normal synthetic division, then right here, what's in our trash can would be our remainder. And we'd have to do a special thing with the remainder. But for factors, you're never going to get a remainder. If you did, something's wrong. Because if something is a factor, and we were told that x plus 3 is a factor, if it's a factor, then the remainder is always going to be 0. That's how you know that it's a factor. And if you were testing out numbers here, like if we didn't know that it was x plus 3, you would keep testing out numbers until you have 0 in the trash can. So if there isn't 0 in the trash can, then you either did something wrong and you need to check your work, or you just need to try out a different number. But in this case, we know that x plus 3 is a factor. So what does this tell us? Well, we've confirmed that x plus 3 is a factor, like the problem told us. But we also have this here. And this is going to tell us what we have left over after our division. Like, remember what I said about 20 turning into 5 times 4. If you divide by 5, you have 4 left. And then as someone in the chat pointed out, yeah, then the 4 can be split up into 2 times 2. So that's how we're going to do this. So this is how we write this out. This number here to the rightmost number is going to be by itself. And then each number after that, we're going to add an x. So this is going to be the number next to x, and this is going to be the number next to x squared. And if we had more numbers, then it would be x to the third, x to the fourth, and so on. So I'm going to erase this real quick, and I'm going to move this up. So here's how this is going to work. 1 times x squared, remember 1s can be invisible. So this is just going to stay as x squared. Then here we have 2 times x, so 2x. And then the -8 is by itself. So we've divided out this big cubic equation by x plus 3. So what does this tell us? Well, this tells us that if we multiply x plus 3 times this, then we get this. So this is our other factor. But let's go back to our example of 20 being 5 times 4. So 5 times 4 are factors of 20. But it's possible that the 4 that we got could also turn into more factors, like 2 times 2. So we need to check to make sure that this can't be factored again and split up into more factors. So the way that we factor is like I was talking about before, but it's like the easier method because there's no number in front of x squared. So to do that, we just need to find two numbers that add up to positive 2 and multiply to get to negative 8. So what are two numbers that multiply to negative 8 and add up to 2? Well, we're going to check negative 8 first. I always check the multiplying number first. So we're going to ignore the minus sign, like I said before, and we will take our factors of 8. So for example, 1 times 8 is 8. And because we're adding to a positive number, I know that the negative, in this case, we have to put a negative sign on the smaller number. Because if we were to put a negative on the bigger number, then we're going to add up to a negative number, and we're adding up to a positive number, which means that our negative is always going to be on the smaller number. So if we add these together, because negative 1 times 8 is negative 8, but if we add them, we get 8 minus 1 is 7. And a 7 is not the number we're looking for. So this is wrong. What about 2 and 4? Because 2 times 4 is 8. And because we're adding to a positive number, we need to put the negative on the smaller number. So we have negative 2 plus 4. That's the same thing as 4 minus 2, which is 2. And 2 is our magic number because that's the one we're looking for. It's 2. It's right here. So negative 2 and 4 are our magic numbers, and we get to skip the whole weird x step. If you are not already given the x plus 3 as a factor, rational root here. Some polynomial. Yeah. I mean, yeah. So the way I would do it is just trying out synthetic division. But yeah, I'm not sure. I've never heard of the rational root theorem. Interesting. Yeah. That's cool. Yeah. There's probably multiple ways. There's always like multiple ways to do these kinds of problems. So our magic numbers are negative 2 and 4. So we're going to put them in our parentheses. So we have x times x here, and no, not equal 0. We don't have to have equal 0 because it's not an equation. So we put in our magic numbers, negative 2 and positive 4. And we don't have to solve this because we're not solving for x here, right? We're just finding factors. So these are the two other factors. Or I guess I can just underline, yeah. So these are our two factors, x minus 2 and x plus 4, in addition to x plus 3. X plus 3 is also a factor. And if you multiply these three out manually, like if you were to check your work and multiply these three things out, you would get this, x to the third plus 5x squared minus 2x minus 24. So that's how you factor cubic equations and also equations that are more than cubic, like what would be like if x to the fourth, just x to the fourth equations. You would do it the same way, but you would have to do 2 steps of synthetic division. So you would divide once, that would turn it into an x to the third equation, a cubic equation, and then you have to do it again. So I hope that's not in your exam. But yeah, this is how you would do it. You divide it out using synthetic division to find the other factor, but then you have to make sure that that can't be split up into more factors. If it can't, then this is just your other factor, and then it's just x plus 3 and this. So yeah. All right. So that is problem number 7. So we have 3 more to go, but feel free to ask questions in the chat about either the problem that we're doing or just request different kinds of problems. I know that last stream, someone asked for a unit circle problem. We talked about the unit circle. Someone was asking about geometric sequences, which we're going to talk about in a little bit, and other things like that. So let's move on to question number 8. Question 8 is, okay. Oh, okay. So for this one, we need to switch to our graphing whiteboard. So I'm going to go full screen for just a moment. And we will switch over to our graphing board. One moment. Okay, so this is question 8, and for this one, we need to graph this equation. So there's two steps to this. We need to graph this equation, and we need to find the domain and range of the equation. So how are we going to do that? First, let's go ahead and graph this, because domain and range is easier to do once you've graphed it already. It's a lot easier to see what we're doing. So for graphing, the basic rule of graphing is that, like, for example, uh, remember left and right is the letter X, and up and down is the letter Y. That's really important to know. And remember that for graphing, you can graph anything. I'm going to do a little hydration. You can graph anything by plugging in numbers for X, seeing what you get for Y, and then plotting them on the graph. So for example, if we were to plug in, 0, and let's say that we get, -1 out, which I think is actually true in this case, then if you plug in 0, that means you're not going left or right, but you get out -1. So that means for Y, you're going down 1, you'd put a point right here. And then you would just put a bunch of points and connect them up. But, and this is the kind of problem that I've done like many times, and that is we can use transformations. That will make our lives easier. So transformations is basically you take a parent graph, which is basically the simplest kind of equation you can get out of this. So in this case, our parent graph, like for example, your parent graphs can be y equals x squared. You can have y equals the absolute value of x, y equals x. You can basically as simple as you can get. But for this, in this case, we're actually going to be using for our parent graph y equals the square root of x, because that's what we have here. We have a square root of x. So what we have to do for transformations is we graph y equals the square root of x, which for every square root problem is going to be the same every time. So that's why we do this, because you can just keep graphing the same graph over and over for every problem. And then all we have to do is figure out what this 2 is doing to the graph and what this -1 is doing to the graph. So first, let's graph our parent graph. Y equals the square root of x. How do we do this? Well, we'll just do what I was saying before. We plug in numbers and see what we get. So what if we plug in 0? If we plug 0 in for x, then we'll get the square root of 0, which is 0. So 0, 0 is just right in the middle. Now what if we plug in 1? Well, if we plug in 1, the square root of 1 is 1, because 1 times 1 is 1. So one of our points is 1 for x, 1 for y. X is left and right, so we have to go 1 to the right, and then 1 for y, which is up and down. So we'd go up 1, and we'd have another point right here. Now, what's the next number we're going to test for x? Well, we could plug in 2, but then we get the square root of 2. And you could put that in your calculator. I think it's like 1.41 or something. You would plot a point like right here. But I don't want to do that. I don't want to deal with fractions and stuff because that's just like estimating. So the next number that would make sense to plug in for x is actually 4, because that's our next perfect square, because 2 times 2 is 4. So I know that if we plug in 4 for x, the square root of 4 is 2, exactly. So when we plug in 4 for x, we get out 2 for y. So x being 4 means we have to go 4 squares to the right. 1, 2, 3, 4. And then 2 being y means we have to go 2 squares up. So that's 1, 2. And we plot a point right here. And of course, we could plug in more numbers as well, but the next number that would make sense is 9, because that's 3 times 3, and that's going off the graph. So we're not going to do that. Now, for any normal graph, you would also want to plug in negative numbers to get the whatever's on this side. But there's a problem with that. If we plug in like -1, you can't take the square root of a negative number. The only way to do that is with imaginary numbers, as I was talking about earlier. But we can't put imaginary numbers on a graph because they're fake. They don't exist. Well, technically we could, but we have these things called, what is it called? It's like a complex plane or something. There's like a special kind of graph that shows complex numbers, but that's not what this is. We're not dealing with that. So actually, there's not going to be anything here on the left side of our graph because we can only put in positive numbers. So these are the only dots that will fit on our graph. So we can connect them up with a line. So it's going to be like a curve like this. And we'll put an arrow here to show that it goes infinitely. We do not put an arrow here because this would mean that it goes infinitely this way, which it doesn't. So there will be no arrow there, but there is an arrow on this side. So this is our parent graph. And if you were doing any sort of square root graphing, this is what you would put for your parent graph every time. So you can basically memorize this 0, 0, 1, 1, 4, 2. Like you just plot this every time. And that's why we even do this in the first place. So now we just need to figure out what our transformations are doing. So let's go and switch this to, okay. So first let's figure out what, the 2 is going to be a little harder, so I'll show you the -1 first. So what is this doing? Well, we're subtracting 1 from y. We're taking whatever we get for y, and then we're subtracting 1. So subtracting 1 from y means that we're moving everything down because y negative is down. If we moved it up, we would move it up if it was like +1, for example. That would move the whole graph up. But because it's -1, we have to move the entire graph downward. So we can take each of these points, so like this point here, this point is going to move 1 square downward like this. This point is going to move 1 square downward like this. And this one is also going to move 1 square downward like this. And we're just going to regraph it and connect them up. So there we go. So that is what, yes, okay. So that is what the -1 is doing to our graph. But we have one more transformation, and that is the 2 here. So what is this 2 going to be doing to our graph? Well, this is multiplication, right? Because we have a number next to the square root and there's no sign. Whenever there's no sign, that means multiplication. So we're taking whatever we get for y and we're multiplying it by 2. So that means that however many spaces it is above the ground, so think of like the ground is like right here, right? We need to bring it double as high as it was before. We're multiplying it by 2. So this point here is going to stay exactly the same. But this point here, it's 1 square above the ground. So now it's going to be 2 squares above, and we're going to put a point right here. So we have these 2 points. And now what about this point here? This point is 2 squares above the ground, but we're multiplying it by 2. So now it's going to be 4 squares above because 2 times 2 is 4. So let me redraw that point. So I know that we have a lot of confusing arrows here, so I'm going to go ahead and erase these so I can show you how we will graph this. So we're going to take all of these little black points and we're going to connect them up. And you'll see that it's going to make our graph taller. We call this stretching it. If this was a fraction, like if this was 1/3, then we'd be compressing the graph. We'd be pushing it lower and lower. So this is our final graph. The green is our parent graph and the purple was our work in between. But these aren't actually part of the equation. So for example, if your direction said graph the parent graph and then graph the regular graph, then you wouldn't include this, but you would include the green, which is the parent, and then the black line, which is our final graph. But if it just says to graph it, you don't need this either, because that's just part of our work. So this is the final graph of y equals 2 times the square root of x minus 1. Now, if you didn't want to do transformations, if you just wanted to do it the same way, where you plug in a number for x, see what you get for y, then you can do that too. And it's going to give you exactly the same thing. If you plug in numbers here, then it should give you the same points on this line. Yeah, it would do the same thing. But yeah, you have 2 choices there, but transformations, once you get the hang of it, is the faster way to do it. And if it said you needed to describe the transformation, then you would just say what you're doing to the graph. So the -1 is going down 1. And then the 2 is, you would call this stretching by a factor of 2. So that's how you would describe it. Beautiful handwriting. It's so good, yeah. Okay, so I did say that we also need to find the domain and range. This is probably going to be one of the most common things you have to do, uh, maybe for your exam. I know for homework, it was like the most common thing ever. It's like for every single problem, even if it had nothing to do with domain and range, it's like, and state the domain and range. So it's helpful to know what those words mean. So what is domain and range? Well, let's look at our domain first. Domain is all the numbers that you can put in for X. Range is all the numbers you can get out for Y. So how do we figure out what numbers we can put in for X? Like, can't we just put in whatever number we write? At whatever number we want. Actually, no, we can't, because the problem that I talked about earlier, you can't put in negative numbers. So, and you can see this on our graph too. X is left and right. So normally what you would do is you would say, okay, I want to plug in 2 for X. So that's 2 squares to the right. And you would go up until you hit the graph and see where you hit it. But if you plugged in a negative number, like for example, -3, it doesn't hit the graph anywhere. So that's not part of your domain. The only parts of your domain is anything that's not negative. So how are we going to write this? There's so many different ways to write it. One way, which I think just makes the most sense, is to say that X has to be greater than or equal to 0. So if the number is bigger than 0, then you're good. It's on the graph. But this line underneath is or equal to. The line underneath is basically saying that, hey, exactly 0 also counts. So we can allow exactly 0 as well. If there was no line underneath, then that would mean that exactly 0 is not part of it, but anything that's bigger than 0 is. So that's one way we can write that. Another way that we can write it is with like parentheses and brackets. So we can say the two numbers that we can go to. The lowest number is 0. We can go anywhere from 0 on to infinity, because infinity, like, we just go on infinitely. Any number between 0 and infinity works. Now, if the number is included in the answer, you would put a bracket. So 0 is included. But if the number's not included in your answer, then you put parentheses. And we put those around infinity because you can't actually put in infinity. It's not a number. So I know this looks a little weird because we have one bracket and one parenthesis, but this is actually how you would write it, because 0 is included, but infinity is not. So range, we're going to basically just do exactly the same way, but it's the numbers that you can get out for Y. So looking at our graph, what's like the lowest number you can get for Y? Well, if we go down 1 square, that's going to give us -1, right, for Y. That's the lowest we can go. We can't put in anything else in this area. None of this is part of our graph. So only numbers at -1 or higher are going to work. And I know that it looks like this graph is like starting to stop, but this is going to keep going on infinitely upward. So any numbers -1 or higher work. So we're going to write it the same way as our domain, except it's going to be numbers greater than or equal to -1. And then we'll write it the same way. We're going to put a bracket because -1 is included in our range. And then we're going to go anything between -1 and infinity works. But we're going to put parentheses around infinity because infinity is not a number. You can't put it in infinity. So that's how you find domain and range. You can do that with any graph. Any graph you can find its domain and range. And it's a really helpful thing to know because it basically shows up on almost any graphing homework assignment. So I would bet that it probably shows up a lot on exams too. But you can always ask your teacher if you're not sure. All right, we have 2 more problems that I have written down here. So I'm going to go ahead and go back to full screen, and we are going to switch over to back to our normal whiteboard, and we're going to do a problem on geometric sequences because someone was asking about this earlier. That was actually one of the few things that I don't know if I ever learned in my algebra class back in high school, but I looked it over in the textbook And yeah, makes sense. So I'll be going over that with you guys. All right. So question 9, we have 2 more problems. So this might seem a little weird, but here's the problem. We need to write an equation for this geometric sequence. And all we're told is that wait, hold on. Gotta use the thicker markers. Okay. So all we're told is that a sub 4 is equal to 128. And we're told that r is equal to 4. And we need to write an equation for the geometric sequence. That if you that's just what are we looking at, right? Well, here's what these mean. I'm gonna explain it in normal human being terms. So a geometric sequence is just a fancy way of saying like multiplying by something over and over. So the classic example that I feel like textbooks use a lot is like a viral video. So, for example, let's say that you have like 2 friends and you all saw a really funny video, right? That means that 3 people have seen the video. So, in round 1 of this video, it has 3 views. Now, let's say that each of you and your 2 friends, they each share it with 10 of their friends. So that would mean that you're multiplying by 10. So if each person in your group of 3 shares it with 10 people, well, now in the second round, 30 people are going to see it. So that's our round 2. And in this case, we would actually call this A2. This is our little geometric sequence term, A2, and this is A1. So now let's say that those 30 people are like, haha, that was hilarious, funny meme. And they're like, I'm going to share it with 10 of my friends. If each of them does that, then the next go around at A3, 300 people are going to see this hilarious video. And then you can keep going. Then all 300 of those people are like, I'm going to share it with 10 of my friends. And then 3,000 people are going to see it. And that's A4. So that's a geometric sequence. It's just multiplying by something over and over until it gets ridiculously big. So what is this telling us? Well, A4 means that this is the 4th term in our sequence. This is round 4 of our video sharing or whatever. And then r is what we're multiplying by. So in that last example, r was 10 because we're multiplying by 10 every time. But in this case, r is 4, so we're multiplying by 4 every time. So how do we write an equation for our geometric sequence? Well, the standard form, because like, for example, a straight line has the form y equals mx plus b. So for sequences, we also have a general format. So the general format is a n is equal to a1 times r to the n minus 1. I know this seems really confusing, but you can even think about this logically as well. N just means any number. So let's think of this as a4. This is saying that a4 is the same as a1 times r, and we're multiplying by r, n minus 1 times. If n is 4, then 4 minus 1 is 3. So to find the 4th term, you take the first term and multiply it 3 times. That makes sense, right? You take the first one, you multiply it 3 times, now you're on the 4th one. So it's kind of, in this case, these are kind of like, these stay the same. When we have our general equation for a geometric sequence, these are kind of like x and y, where they just stay the same. But the only thing that changes is a1. So we plug in a1 and we have our equation. But we don't know a1. So to find a1, we need to plug in what we know and then solve for a1. And a1, remember, is just our first term. It's the 3 in our last example, where you had 3 friends to start off, and then they just kept sharing it. So let's plug in what we know. In this case, we're going to use a to a4. So yeah, so I'm gonna rewrite this actually. We're gonna rewrite this to show we can use any number we want as long as, if, for example, if we use a4, then the number we use for r has to be 4 minus 1, which is 3. So let's plug in what we know. A4 is 128. A1 is what we're trying to figure out. And then R to the 3. So this is R times R times R. So R is 4. It's going to be 4 to the third power. So let's go ahead and simplify this more. So 4 to the third power is 4 times 4 times 4. So 4 times 4 is 16. Times 4 is 64. You could put that in your calculator if you weren't sure. So now to get A1 by itself, we just need to recognize this is multiplication, right? Because there's no sign. So the opposite of multiplication is division. We'll divide both sides by 64. So the 64's cancel out. And on the left side, we just have A1. And on the right side, we have 128 divided by 64. You could put this in your calculator, you'll get 2. So 2 is the first term in our sequence. And if you weren't sure, you could test it out. If our first term is 2, then to get to the fourth one, we just multiply by 4 a bunch of times. So times 4 is 8, times 4 is 32, times 4 is 128. And this is our fourth round because 2 was our first, second, third, fourth, and it checks out, right? 128 is what we started with. So that means we did it correctly. And we now know that our first term is 2. And remember that for the equation of a geometric sequence, all we have to plug in is A1. Everything else is going to stay the same. So we're going to rewrite this, except we're going to, oh, wait, hold on. Yeah, sorry, I've been saying that you don't have to change anything else. We actually have to change the R. The R is 4 in this case. That's my bad. But the n is going to stay the same because it's designed so that you can put in any number for n and test it out. So if you wanted to find out your sixth number in the sequence, then you'd put in 6 here. This would become 6 minus 1, which is 5. So you would have 2 times 4 to the fifth, and that will give you your sixth term. So that's what the equation of a geometric sequence does. So yeah. So that's geometric sequences. I hope that was clear enough because, yeah, I literally just went over this today. But yeah, this is how you would do a geometric sequence. So for the last problem, I wanted to go over logarithms because it's something that I've gone over in the past videos, but I kind of just went over the basics of what a logarithm is. This time I want to go a little bit deeper because normally you don't just go over what a logarithm is. There's also something called properties of logarithms. So let's go ahead and write our last problem. So we need to solve this. We need to figure out what this is equal to. So if you're not sure what a logarithm is, let's go over that first. A logarithm is basically the opposite of an exponent. So for example, if you had log base 4 of 16, to solve this, what a log is, what it's asking for, is it's asking what exponent do you have to put on the small number to get to the big number. So it's saying 4 to the what is 16. And in this case, you have to put an exponent of 2 because you have to multiply 4 2 times to get 16. 4 times 4 is 16. Or if you had log base 4 of 64, well, now the answer is 3 because you have to multiply 4 3 times to get 64. 4 times 4 times 4 is 64. So that's what a log is. The problem is that it's not very easy to do with this. Like log base 8 of 2. What exponent do you need to put on 8 to get 2? Well, that doesn't make sense because 8 to the 1 is 8, and 8 to the 0, anything to the power of 0 is 1. How do you get 2? Well, you would have to take a fraction exponent, and that's just kind of confusing. We don't want to deal with that. I mean, you could put this in your calculator, and I will show you how to do that because it's important at the end of this problem. But there's actually a special rule that we can use with logarithms. So you can combine logarithms and stuff. You can do all fancy stuff with them as long as the bases are the same. So if the small numbers are not the same, you can't do this. But if they are the same, then you get some cool little powers. So if you add two logs together, then you can actually combine them into one log, one super log. And to figure out the new number, you have to multiply these together. So 2 times 32 is 64. And this is your new log when you combine these. If these were subtracted, like for example, let's say we had log base 8 of 32 minus log base 8 of 2. If you subtract them, then it's the same thing, except you would divide instead of multiply. So you would do 32 divided by 2, which is 16. And this would be your new super log. So that's one thing that you can do with logarithms, as long as they have the same small number. And now you'll see that this works very well because we have log base 8 of 64. Well, this is pretty nice because 8 times 8 is 64, which means that we need to put an exponent of 2 on 8 to get 64. So our logarithm is 2, and 2 is our final answer. So that is how you would do logs, like combining logs together. Yeah. Now, this isn't one of the problems I wrote down, but I also want to go over what would happen if you had like log base 7 of 32. Like, this would be a confusing mess of decimals, and no one wants to do this, right? Well, here's how you can put any log into a calculator. It might seem like this should be super easy because you have a log button on your calculator. I'm seeing here I have a log button. Actually, it shows you this on an iPhone calculator, which is what I have open right now. It says, like the button literally says, um, the button says log 10. So it's telling you that it's only going to be base 10. And that's actually the only base you can do for a logarithm on a calculator, like with the button. Some calculators just will say log, but it means the same thing. If you don't include the little base, that means it's 10. It's like assumed. But you can actually put in any base logarithm in your calculator. You just have to do an extra step. So what you're going to do is you're going to take the log of the big number and just assume that it's 10. So you put in your calculator, say log 32, and you would figure this out. So I'm going to take the log of 32. But then you have to, wait, will it let me? Okay, it will. With the scientific calculator, it lets you put in multiple things at once. So you're going to take whatever you get for log of 32, but then because it's a different base, you have to divide it by the log of the small number. So you have to divide it by, or if you're putting this in your calculator, it would also look like, division symbol. You divide it by the log of 7. And this is going to give you your log of 32 base 7. So if I put this in my calculator, it gives me about 1.78. And that would be your answer to that logarithm. So that's how you can put any log into a calculator. If you have calculators available for your test, then you can literally just put it in your calculator. Like if you forgot how to do something, then this can actually save you that step. I mean, if you don't have to like show your work and stuff, which you probably do. But yeah, that's one way to do a logarithm, and it's important to know in case you have to do those kinds of things. Also, a type of problem I've seen is sometimes it will, for example, I've seen homework problems where it's like log um, base 3 of 15. You can't really do this, right? You have to put in a calculator. But the problem will tell you that assume log base 3 of 5 is da 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 da, and log base 3 of 3 is da 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 da, and it will tell you find log base 3 of 15. So you don't actually have to even, well, I mean, you have to use your calculator to multiply, but you don't have to use the log button. You would just have to know that this is the same as log base 3 of 3 times log base 3 of 5. and then you would plug in this number here and this number here. So yeah, just like you can combine logarithms, you can also split them up the same way. So yeah, so those were the 10 problems I had planned. Does anybody have any questions about anything related to the problems we did, or a type of problem you'd like me to do to prepare, or just some general study tips? Because yeah, like one of my favorite ways to study basically for math, I think the best way is to just do example problems. Uh, and I remember last stream someone was asking, I feel like I'm watching the math and I'm memorizing it, but I'm not understanding. And that's like really important. The most important part for math is that you're understanding it. So the way that you can tell if you're understanding or not is to just try to do a problem yourself. Grab a pencil and paper and try to do the problem, work it out on your own, pull out a random problem from your textbook, or pull out a homework problem or a test problem that you got wrong originally. And try to do it yourself. And then go back and see how you did. And then find out where you made a mistake. And then learn from your mistakes. So if you uh, the example I gave last time was if you did the whole problem and you did everything right, like you understood how to do it, but you missed one negative sign. Well, that's very different from if you just didn't know how to do it in general, right? If you missed a negative sign, you can just tell yourself, all right, I'm going to watch carefully for negative signs next time. And then you'll probably stop forgetting negative signs, or at least forget them less often. But if you weren't sure how to do the lesson in general, then that can tell you that you should go and watch a video on how to do it. But you don't have to do that if you just made like one little negative mistake. So yeah, if anyone has any questions, let me know. If not, then I will end the stream here. Is anyone like done with finals? I mean, I would assume that uh the people watching right now probably still have their finals coming, but yeah, because everyone has their finals at such a different time, and I was surprised by how early some people had them. But yeah, I feel like I usually had them kind of later than most people. Well, actually, no, I didn't even have finals because of COVID and stuff. But yeah, we were supposed to have finals, and then we didn't. But yeah, those are my study tips and everything. So I'll wrap up the stream right there. Thank you guys for watching. And those of you who are watching live, or if you're watching the VOD, I do have another stream that you can go watch if you want. I do 10 more problems there, and I answer some chat questions in that one. And I also just have a regular finals video that you can use to study. I have all sorts of random videos with different things that I didn't talk about, because there are all sorts of other math topics that I wasn't able to cover in this video, such as long division. I didn't do that in this video or this stream. Um, let's see. What else did I not do? I didn't do other stuff. Oh, graphing a straight line. I didn't do that in this one, but I've covered those in the other streams and videos. So if you want to go watch those afterwards, then you can. But yeah, that will be it. Thank you for watching, everybody, and good luck on your finals. Keep studying, and I'll see you next stream if I do another stream. I don't know. All right, bye. Thank you guys for watching. Good luck on your finals.